get started. So we're talking about method 25, calculus 2 again. And now we introduce more integration technique. And the most first integration technique that we need to use method 25 is integration by part. And the integration by part is more useful to integrate the product function. Integrating product function. Like if we have integral like this, then it's the way that we can, but it's now like reverse the product rule that we taught in method 24. And how integration by part work, it is like we choose, here's the how the definition of IVP is if we have a U and dv, this is the integral, and we choose like the v, and this is a function of u of x, and equal to is like uv minus v du. And we need to choose 4 counterparts. It's like 4 components of this integral, how to solve the integration by part. And we need to choose u du and v dv. So if you choose u, and then dv is everything else. So the tips is when choosing u, always make sure that you can find you can differentiate u just right away. So it's like and there are more part of it, there are different type of IDP. That we need to focus on. So type 1. Anything involves effects. And want to make something that is easier to integrate. So let's do an example. Evaluate the integral. We have this, perhaps it is x ex dx. So careful choosing what is a u and du. It is like if you choose the u, make the du just nicer. Choose return that will produce a nice looking du. So in this cases, we will choose u equals to x, the du is dx. U equals to x, du equals to dx. It's just much easier, right? And then dv is everything else. So once you choose what is u, the dv just everything else. It is dx, dx, the v is dx. And number 2 is, and just the integrating will be, we can just have this is x dx dx. I didn't mean to do that unintentionally. It just uv minus v du. So uv is xex minus v du ex dx. So it is just x minus x plus constant of integration. And now we're gonna try another one. Example 2. evaluate the integral. This time, yep, is this one, x squared e to the 12x. First thing, integration by part. Is we choose x squared, which will be like, because like sometimes you might use integration part more than once, and this is unavoidable. And because the uv minus 1/12 and 2x e12x dx. We need like another kind of u substitution here. So we just write as x squared e12x over 12 minus 1/6 x e12x dx. In this case, we need to let u equals to x because dx will be a lot more nicer. So let the u equal to x, du equal to dx. Then dv, it is e12 x dx. V, it is the 1/12 e to the 12x. And we just do another thing. This part remain unchanged. We minus uv gonna be 1/12 x e12x minus v du minus v du. It is e12x dx. And then it's integration here. You have this a square e12x over 12 minus 1/72 x e12x plus it's going to be 72 So is 144 is 840, 864 plus 1 over 864 e to the 12x dx. But no, plus constant of integration. Sometimes you need to use more than once for integration by part. Let's do another example. Example 3. Evaluate the integral what we have is we're going to be 15 minus 10x. Oh no, 15 plus 10x is 5x. dx. The thing about what is the u make du a lot more nicer to further integration, then we need to choose u equals to 15 plus 10x and du is 5x. It don't need to multiply because this is like a product function, just don't multiply it. And then we can put the uv minus v du gonna be minus 2 over e5x dx. We're gonna multiply going to be 3e5x minus so it's gonna be 3e5x plus 2x e5x. Would it be minus 2 over 5 e5x plus constant of integration? Okay, then let's try more about like a natural log integration by part. Evaluate the integral like a natural log of x dx. Okay, this seems tricky. Oh wait, tricky, but natural log of x on x is the only function that is, I don't even know what is the derivative immediately. So we let u equal to natural log of x. du it is 1 over x dx. And natural log times a 1. If there's just a nothing, just a 1. So dv it is 1 dx. B equals to x. And then integration would be x natural log of x minus, it's going to be 1 v du, going to be 1 dx, going to be x on x minus x plus the constant of integration. Well, I would recommend to add this to the integration table because if you're involving anything with it, natural log of x, put them into, so put them in there. So I recommend putting the integration table. And let's do another one. Still natural log, because there are like 3 types of integral that we were just talking about. One is like e of x and natural log of x and some trig function. But there'll be more trig in section 7.2, but they have some in this part of it. Moving to the integral. Cubic natural log x dx. So we choose u equal to natural log of x. And du it is 1 over x dx. And dv it is x cubic dx v 1 over 4 x to the 4. And integration is uv times v du. So it's going to be 1 over 4 x to the 4 times natural log of x. Minus is 1 over 4, it is here, v du. It's a constant, we pull it out. X4 is going to be x 1 over x, it is x power x exponent to -1. So we multiply, it's going to be at the power is going to be addition. So from 4 plus -1 and then to 3 x to the cubic dx integration f is 1 4 x to the fourth natural log of x minus 1 over 16 to the fourth plus constant of iteration. And here, now there are lots of indefinite integrals. Let's just shift the focus to definite integrals. So for any definite integral, and we do this is B A U D V. It is equal to U V B over A minus B A V D U. This is how we do the definite integrals. And note that we don't need to do U substitution in this case, unless it's like when doing UV and DU, we don't need to do in U sub, but later integration we will use. So let's do an example here. Evaluate the integral. So in this case we will let U equals to natural log of x plus 1, and then du, it is 1 over x plus 1 dx by chain rule. And dv, it is x squared dx. V, it is one over 3 x to the cubic. And by the equation, we will know that it's going to be 1 over 3 x to the cubic natural log of x 2 to the 1 minus we have x squared and this minus, and it's the 1/3 of integration going to be 2 and the 1. We have x to the cubic over the x plus 1 dx. Okay, don't panic, all right? It's we can solve this problem. It's like if u equals x minus 1, then u minus 1 is x. We have as a u minus, and it's all going to solve it. Don't panic. it's all gonna be good. And if we do x plus 1, I'm so sorry about it, gonna be 8/3 natural log of 2 plus 1/5 3. Minus 1/3 natural log of 2 minus this messy integral. But you couldn't solve it because using partial fraction it is longer. Yeah, so we use some other method. I will show you the magic. Trust the process. Is that the way I can just show you that this is the magic that I solved the problem. You got u, but now we need to do the u sub of this integral. So u equals 2 x plus 1 du is dx. Then x equal to u minus 1. Then we have this. It's going to be 8/3 natural log of 3 minus 1/3 the natural log of 2. That's the 1/3, going to be 3 and 2. Going to be u minus 1 to the cubic over u and then du. Here's some algebra trick, but I was just gonna solve this trick. What is a, and what is like a u minus 1 to the cubic? And back to it, it's gonna be 8/3 natural log of 3 minus 1/3 could be natural log of 2 and minus 1/3 gonna be 3/2 u minus 3. That's the u minus 1 to the cubic over u du. And then expand. I know some of them are just so long, right? So it's going to be u to the cubic minus 3u squared plus 3x, no u, then minus 1 over u du. Then do like another 8/3 natural log of 3 minus 1/3 natural log of 2. And then you just do this 1/3, 3, 2, going to be u squared minus 3u plus 3 minus the 1 over u du. And then just gonna do the computation. Have is 8 over 3 natural log of 3 minus the 1 over 3 natural log of 2. New 3 minus 1 over 3 u cubic 3 2. Then we have this mess like another 1 over 3 over 2 u squared 3 2. We have a 3 gonna be plus 1. And then minus natural log of 3 minus natural log of 3, we're gonna be 1 over 3. So it's gonna be 7 over 3 natural log of 3 minus 2 over 3 natural log of 2. And then it just says 9 is connected to 3. It will be 9 minus maybe 8 over 3 minus 1 over 3. It will be 9 over 2, the 27 over 2. 4, 12, 6, and natural log of 3. Wow, this is a long integral, right? 2 over 3 natural log of 2. Plus it's gonna be 27, 3 over 19, gonna be 3 over minus 3 over 19, gonna be 9 over 19. Minus gonna be 22 over 12 with 2 over 15 minus 5 over 2. You don't need to simplify this because this is complicated. Let's do another one. How many examples? 6, numbers 7 should be. Evaluated integral. Dx du equals to x, du equal to dx, then dv it is dx dx, v equal to ex. And integration is going to be x dx 1 and 0 minus 1 and 0 ex dx. It is just x ex when x equal to 1 minus dx 1 to the 0, we get this e minus e minus 1, we get this e minus e 0 plus 1 is a 1. Is that easy? Right? 1 is the answer. And now we're going to introduce another type 3, when there are the trig functions. Now let's try example here. Evaluate the integral x sine of 8x dx. Well, the first thing is like, no matter what kind of a use of you're going to use is, you have to do IVP. It's not going to avoidable, right? That's the thing that they have to use it. If we let u equals to x, the du it is dx. And then the dv it is sine over 8x dx. The v is going to be negative 1 over 8 cosine of 8x. Then the integration will be going to be negative 1 over 8 x cosine of 8x minus plus sign. Make sure to swap the sign again. It's going to be 1 over 8 cosine of 8x dx. Then just integration, use substitution, we have going to be negative 1 over 8 x cosine of 8x plus 1 over 64 sine of 8x plus constant of integration. Let's do another example here. Example 9, evaluate the integral is, if you choose is ex sine of x dx. This is going to be an interesting integral that we will have for today. And it will just to see is if there's ex in the sine of x in a trig function, pick up the u as a trig function. As exponent and trig function that u equals to the trig function. Sine of x du, it is cosine of x dx, and dv, it is dx dx, v, it is dx. Your integration is going to be uv, it is dx sine of x minus dx cosine of x dx. Let's use it again. U equal to cosine of x du, it is a negative sine x dx, and dv is dx dx, v, it is dx. There's a whole lot of mess here, right? Back here, it is equal to dx sine of x minus uv is dx cosine of x minus v du dx plus minus plus dx sine of x dx. Now here's the magic. If the integral it is let's say EX sine of X minus EX cosine of X minus integral again EX sine of X dx. So did you see the same integral applies appeared twice, right? Then combine, it's going to be 2 of dx sine of X dx. It is dx sine of X minus EX cosine of X. It's just divided by 2 on both sides. We have integral of EX sine of X dx. It is 1/2 EX sine of X minus EX cosine of X. That's it. Let's do our last example. That's going to be on trig function here. We're going to do something on a trig function. Inverse trig function. It is like the integral inverse tangent of X dx. We let u equals to tangent of X. No, u equals to X, then du dx. Then v equals to tangent of inverse tangent of X. For this kind of a part, we can let the u go way nicer. Then in this part, we let to u, it is you can pick the choice. U is the tangent of X, inverse tangent of X. U, it is going to be 1 plus X squared dx. dv, it is dx, v equals to X. This equal going to be X inverse tangent of X minus dx X over 1 plus X squared dx. U substitution, that u equals to 1 plus X squared du. It is 2x dx. Then we have going to be X inverse tangent of X. Going to be over 1/2. It's going to be 1 2x, and x will be canceled. It'll be 1 over u du. It's going to be x over tangent of inverse tangent of x. And then minus 1 over 2, going to be natural log of u plus constant. When do you use substitution for indefinite integral? Always replace the term back to it. My answer, it is natural inverse tangent x times inverse tangent minus 1 over 2 natural log of 1 plus x squared plus constant of integration. Okay, that's all for 7.1 IBP. And in next video, section 7.2, we're going to be talking about integrating trigonometric product functions. Thank you guys for watching and have a good day.